In the last section, I mentioned that closures were more often better left for use with immutable variables. However, in Spark, even this can possibly cause problems, although minimalized since version 1.1, which we'll review after getting a better understanding of the problem. First, we'll expose said problem by creating a map that we'll use to transform our RDD values. Notice that we're closing over this map, which means that a copy of it will be distributed across the cluster for each execution. And what if this map takes up 1 megabyte of space? Let's visualize that. Here we have a driver along with 3 worker instances. The driver first creates our 1 meg map. Then, once an action is called and the RDD begins execution, and each time the worker executes the function, it gets a new copy of the map. So, this 1 meg map becomes 4 across the network. And that's just 1 worker. This will happen in parallel for each worker across the entire distribution. And the end result is that 1 megabyte map quickly balloons to be a much larger footprint across the network. This small, simple example becomes 11 megs. Just imagine running this against a dataset in the millions. So, that's the problem. Our closure may not mutate, but it sure grows out of control quickly. That's where broadcast variables come into play. We simply wrap our map in this call to the Spark context broadcast method and pass that into our closure, accessing our wrapped map via its value property. We're still passing a trapped variable across the wire. However, while the map itself remains 1 meg, the broadcast variable we're trapping is much smaller, as it's only used to retrieve the map on the worker. So, what's happening behind the scenes? Well, our driver still has to create this 1 meg value and wrap it up. But then, instead of going across the wire for each execution, it only goes over the wire once for each worker. The workers then cache their version of the map for retrieval via the broadcast variable's value property. So, now the network footprint is merely the size of the map times the number of workers. But even that can be improved, as there's still a bottleneck of the driver being the single point of distribution. In fact, this approach has enough overhead that the communication cost could offset the benefits as machines are scaled up. So, starting in 1.1, the broadcast was changed to default to a more BitTorrent style, which keeps the communication overhead constant while scaling. But what does this mean? It means that once one worker receives the broadcast's wrapped variable, it then starts to help send that variable around to other workers. As anybody who's ever downloaded a torrent knows, this utilization of other network bandwidths can significantly reduce the total distribution time. Now that you have an understanding of how closures and the network can affect your total processing time, and how broadcast variables can alleviate this problem, I have good news. As alluded to at the beginning of this section, starting in Spark 1.1, the need to worry about this is minimalized. It was realized that every stage's task could be broadcast behind the scenes. This is because the same function, including everything in it, would be called numerous times. Why not broadcast it? So, you should now only need to explicitly broadcast if your shared variable is used in multiple stages, or you want to cache the shared variable deserialized, as it's serialized otherwise. But it is still useful to understand in those instances where you do need it. And one final note about broadcast variables: they have the opposite role of accumulators when it comes to access. They're write-only on the driver and read-only on the workers. In fact, it's a good rule of thumb to just use an immutable object, signaling this to any future developers.